we're going to talk about a required practical. So the practical is to carry out simple test tube reactions to identify cations and anions. So here is the method, and it's quite long, so feel free to pause the video and just read it first. But for the first thing that we do is test for group 2 metal cations. So everything that's highlighted in orange are the different experiments that we're going to do. So for the first experiment, we've got two parts. The first is adding dilute sodium hydroxide, and the second part is to add dilute sulfuric acid. So for part one, the first step is to place around 10 drops of barium chloride into a test tube, and then you add around 10 drops of sodium hydroxide into that solution, and you mix that really well. You then continue to add sodium hydroxide dropwise with gentle shaking until the sodium hydroxide is in excess. So we've got way more of it than we need. So it's all reacted already, but we're adding more and more of it in. And then we record the observations. We then repeat this for calcium bromide, magnesium chloride, and also strontium nitrate. And then for part two of the adding dilute sulfuric acid, we place about 10 drops of the barium chloride into a test tube and add about 10 drops of sulfuric acid, and we mix that well. We then continue to add the sulfuric acid dropwise until it is in excess again and record the observations. We repeat this for calcium bromide, magnesium chloride, and strontium nitrate. So all your observations they should go into tables. So this would be one table when you're testing for group 2 metal cations, and then you would have two rows. So the first row would be adding sodium hydroxide, and then the other row would be adding sulfuric acid. And then the next test that we would do would be testing for ammonium ions. So all of these tests are actually happening in different test tubes. I've just written them out like this, so it's easier to see. So the first step is to place about 10 drops of ammonium chloride into a test tube and add about 10 drops of sodium hydroxide solution and shake that well. We then warm the mixture gently in a water bath and test the fumes released by using damp red litmus paper. And we hold this at the top of the test tube and record the observations. And then the third test we can do is testing for hydroxide ions. And what we do is we test about 1 centimeters cubed of sodium hydroxide solution, and we put that into a test tube with some red litmus paper and record the observations. And then for the fourth test, testing for halide ions, we place 10 drops of potassium chloride into a test tube and then add 5 drops of dilute nitric acid and shake. The reason we do that is to remove all the carbonate ions and some maybe OH minus ions, because they can also form precipitates at the end with the silver plus ions. And so we wouldn't be able to tell whether it was halide ions or if it was just carbonates. And so after that, we then add 10 drops of silver nitrate solution and then add an excess of ammonia solution and mix thoroughly. We repeat these steps, but this time we add excess concentrated ammonia in a fume cupboard to these test tubes. And then we repeat these two steps using potassium bromide and potassium iodide. And then the fifth test that we can do is testing for carbonate ions. And so the first step we do is place about 2 centimeters cubed of calcium hydroxide, which is also lime water, into a test tube. And then we add about 3 centimeters cubed of dilute hydrochloric acid to a test tube with some sodium carbonate. And then immediately we put in a delivery tube to the test tube with the lime water in it. And then immediately we put in a delivery tube to this test tube with the hydrochloric acid and sodium carbonate in, and then put in the open end under the surface level of the calcium hydroxide, and then we record the observations. And then the last test will be testing for sulfate ions. So what we do is we add an equal volume of dilute hydrochloric acid and magnesium sulfate into a test tube, and then we add an equal volume of barium chloride solution, and then we record observations. So now I'm going to quickly run through what kind of results you should see. So for testing for group 2 metal ions, we should have a sort of table that looks like this. So you should have group 2 tests, so metal cations. So this would be in a table format. And so the first row would be the adding sodium hydroxide, and then the second would be adding the sulfuric acid, and then you'd have the chemical, and then this third column would be the observations. And so here you would have the barium chloride, and then the calcium, the magnesium, and strontium. So you'd have calcium bromide and magnesium chloride, and also strontium nitrate. And I'm just going to write them in. I'm just going to write the chemical formulas here. So you can have calcium bromide, magnesium chloride, and strontium nitrate. So what we should get is that all of these chemicals have this reaction of a colourless solution forming a white precipitate. And also the precipitate should become more and more soluble as we go down. So for barium chloride, it wouldn't be very soluble. So white precipitate, unsoluble. And then going down the list, we get more and more soluble. And then when we're adding the sulfuric acid, what happens is that the barium chloride should form a white precipitate. And this strontium nitrate should also form a white precipitate. And then there should be no visible change for these two. And so this is the kind of table you would have set up for all of them. And this is how you would write down all your observations.